Question 13. The number of hours that it takes for a block of ice to melt varies inversely with the temperature. At 30 degrees Celsius, it takes 8 hours for a block of ice to melt. How long will it take the same size block of ice to melt at 12 degrees Celsius? This situation describes an inverse variation relationship between time and temperature. Now, I've let the pronumeral T represent time and the pronumeral capital M to represent temperature. So what that means is, as the temperature increases, the amount of time it takes for the block of ice to melt will decrease, and vice versa. So if I was to double the temperature, say from 30 degrees Celsius to 60 degrees Celsius, it would take half the amount of time for the block of ice to melt, so it'll take 4 hours instead. If I was to halve the temperature, that will double the time. And that describes the inverse variation relationship that's going on here. We could use the inverse variation equation, so T equals K over capital M, where K is a constant. However, I'm going to describe an alternative approach to solving this problem. So rather than using the inverse variation equation directly, we could set it up in this way. In other words, the product of 12 and T must equal the product of 30 and 8. Or 30 times 8 must equal 12 times the pronumeral T, where T represents the number of hours it takes for that block of ice to melt. So solving this equation, 12 times T equals 30 times 8. To make T the subject, I'm going to divide 30 times 8 by 12, so moving this times 12 over to the other side. We get T is equal to 30 times 8 divided by 12, which equals 20 hours. Therefore, the correct answer is option B.